What does it mean for a function to be differentiable at a point? Well, we need a couple things. We do need that the function is continuous. And then what we need is the two-sided limit to exist. So in other words, the limit as x approaches a of f of x minus f of a over x minus a is the same. Notice this is one particular form of the definition of the derivative. You can use the other forms of the definition of the derivative. You can also use just your derivative rules. But basically what this is saying is you need the function to be continuous, and you need the slope, aka the derivative, as you're approaching from the left, to be the same as the slope as it's approaching from the right. So if it's not continuous, we cannot define a slope here. We cannot define a slope or any later derivatives. If it is continuous, but the slopes don't match, then it's not differentiable. You end up with, well, let me draw a little better one. You'll end up with like a corner, or perhaps a cusp. Even though it's continuous, the slope as you're approaching that point from the left is not the same as the slope as you're approaching it from the right. Now, you can have a weird, so when you're given, let's say, a piecewise function and trying to determine if it's differentiable, don't forget to check continuity. There are questions that look like this, where the slopes end up matching, but the function itself isn't continuous. So even though the limit of the derivative from the left approaches the limit of the derivative from the right, these aren't actually connecting, so we can't define a derivative at that point.